Hello everyone, welcome to CSR Term. So I'm starting this video series on low-level design where we will be talking about small but very useful concepts which are used by developers in their day-to-day coding activities. You don't need to know any specific technology for these concepts. The concepts are so that you can apply this in every kind of technology that you are working on. Today's topic is double-checked locking, which is used in multi-threaded environment, especially when we are using singleton objects. Singleton objects are quite common in every kind of design pattern, right? The video will proceed in a way where we will first discuss the concept and then we will move to the coding. So what are we waiting for? Let's start. Now let's take this multi-threaded application where we have 3 threads running parallelly and all the threads wants to talk to the database. So what we can do over here, when thread A wants to talk to the database and fetch something from the database, it will create a database connection and then it will fetch some data from the database. Thread B, again, when it wants to execute a read query, say, or a write query, it will again create a new connection and then it will fetch the data from the database. Similarly for thread C. So do you think this is the right design pattern? Obviously not, right? Because for fetching data from the same database, all the 3 threads are creating its own individual connection. So if we have n number of threads, we will be creating n number of connections, which is misusing of resources, because for a single database, we should have created only one connection object, and from that connection, all the threads should have shared that object to execute their own query, right? So this is not the right design pattern at all. And now moving to the actual design pattern for this, we have thread A, thread B, thread C again and again the same database. Now, what it will do, thread A will try to see if we have any existing connection object or not. If we do not have any existing connection object, it will create a connection object and get the data from the database. Now we already have one object created, right? So thread B will use that existing object to connect to the database. And now if thread C wants to connect to the database, it will use the same object again to connect to the database. So this is the singleton object concept, right? We are creating one object which is shared by multiple users. In this case, users is thread. But can you tell me what is the problem in this design? There is a flaw in this design. The flaw is that suppose thread A and thread B try to access the database at the same time. Okay. So if they try to access the database at say T0 and at T0 there is no database connection present. So as per this design, thread B and thread A both will try to create a new database connection and then it will try to fetch the data from the database. So in that case, our purpose where we wanted to create a singleton object, that will fail. Because we are trying to get data from the database for both B and A at the same time, both of them are creating a connection of their own. So this is not the right design again. Now to solve that problem, what we can do over here is we can apply a lock. So when thread A and thread B wants to access the database at the same time and they want to create the object because the object is not present, the connection object is not present, what it will do, it will try to fetch the lock to access that database object. Okay, we will keep a lock in front of that database object so that whenever a thread wants to access the object or maybe create it, it will have to fetch the key to that lock. So at any point of time, only one thread can pass through this lock, not more than one thread. Okay. So with that, say when thread A, thread B both wants to create the database connection, only one of the thread will get the access. So in this case, suppose thread A got the access to the lock and it created the database connection. and then it fetched the data from the data. Thread B, by this time, after it also requested the lock, right? But it had to wait until thread A finished it, right? So now when thread B, after waiting is over, gets the lock access, it will see that database connection is already created, and so it will not try to create another new connection. It will use the existing one and then try to fetch data from the database. Thread C, again we have applied a lock before the connection, so they have obviously this lock is generic for all thread. It is not particular to A, B or C, right? So since the lock is applied before this database connection, so thread C, regardless anything, it has to pass through this lock, get the access to this lock and receive the database connection existing one, and then it will get the data. So as I explained this design, obviously I think by now you have understood there is again a design flaw for this, right? Because our first purpose was solved when thread A and thread B had tried to create the database connection for the first time. Using that lock, our purpose was solved. But thread C, after nth time, when the database connection has already been created and we do no longer need that lock, it is again it had to wait to get that lock, right? So obviously, when we are having a very high processing application where we need to have very low latency, this unnecessary lock, which is solving only one use case, for that one use case, we are putting extra latency for every thread, right? So this is the problem that is solved by double-checked locking, which we will go from here. So now let's see what double-checked locking is. So what we can do, before the lock, we can put a filter to get the connection. When thread A wants to access the database, it will try to first fetch the connection object. It will see that the connection object is not present. Then it will access the lock. After accessing the lock, it will again try to fetch the connection and see that the connection object is not present. Meanwhile, thread B will also try to get the connection object. In the first stage, it will fail because connection object is still not present, and then it will try to access the lock to create the object. Now, while creating the object, it will see that the lock is already taken by thread A, okay, which is already has seen that the connection object is not present and is now trying to create the object. So, it will create the object, fetch the data from the database, and done. It will release the lock. Now, thread B, when it enters the lock, because it was waiting on the lock, right? So, when it enters the lock, it will see that the database connection is already created. So, it will simply fetch the connection and then perform its activities. Now, for the next one, thread C, before going to the lock, it will again see that the connection is present or not. By this time, in the first stage only, it will pass because connection is already present, and it will get the connection from the first stage only. It does not have to go through this entire lock acquiring story and then again check it. It does not have to do. It saved so much of time for thread C that it got the connection in the first stage. Now again, say thread A wants to take the data from the database. Next time, like this is the second time for thread A, and next time it will see that connection object is already present. It does not have to go to the lock acquiring stage. So from the first stage only, it will get the connection and it will fetch the data from the database. And similarly for thread B and C as well. So do you see the performance improvement just by adding an extra check before the lock? So why double checked locking? This is because we are adding two checks, one before the lock and one after the lock. In the first stage, we are checking if the object is present or not. If the object is not present, we are trying to fetch the lock and acquire the lock. And once we have acquired the lock, then again we are checking that if the object is present or not. And then if the object is still not present, then we are trying to get the create the database connection object. And see, the connection creation object, it is not something that will be happening very frequently, right? It will happen once in a while, maybe during the start of the application, or if the application has crashed and it is trying to recreate the connection. So only in those cases the connection object will fail. Otherwise, we will always have a connection object. So checking every time and trying to get the getting the lock is an expensive activity. So trying to fetch the lock every time to check just that the connection is there or not is not the right thing. So instead, what we can do, we can just create a filter before acquiring the lock, and in this way it will save our time. Now we will go to the coding for this design.
So let's say we have this my database class, and in this class, if you see, we have created a private constructor so that it cannot be so that we cannot create a new object from outside this class. The only way to create the object of this class is through get database instance, where it will first check if there is any existing object of that class is there or not. If there is no existing object, then it will create the object over here with the parameters sent, and then it will set that object in that global variable which we are using to make the check, and then we will be sending that object. So every time whenever any new thread is wanting to access this get database instance, it will not be able to create any object more than once. Okay, and now how we have applied double checked locking over here. If you carefully see this condition, so for example, say thread A, thread B, which we saw in the previous use case. So thread B and thread A are trying to access the get database instance function at the same time, for example. So both of them will come to this condition where it will check whether this instance is null or not. Say there is no instance to it. Okay, so at that time both the thread will pass this condition, and now since we have applied a lock over here, so this is written in C#, so I have used lock. For Java you can use synchronized block. Okay, so here since I have used a lock, so among thread A, B and C, if they are trying to access parallelly, then only one thread will get the lock at a certain point of time, and then after getting the lock, it will again check whether the instance is null or not. If the instance is still null, then it will create an instance and then it will return that instance. Now once thread A, suppose, has released the lock, the thread B, which was accessing it at the same time, was waiting around this lock. So when it acquired this lock, the thread B acquires this lock, then what will happen? It will again check that by this time whether this instance is already created or not. And this time, since thread A previously has already created the lock, the thread A has already created the object, then it will do nothing. It will not create the object again. It will simply send that object, the existing object, to thread B. And after some time, say thread C wants to get the object or create the object again, wants to access this, then it will come here. It will see that the instance is not null, and it will not go inside this lock thing again. It will simply return the object from here. So this is double check locking, and this has been done in C#. It can be done in any language that you are working on.
So here I have given some examples where you can use double check locking. In every scenarios where you are trying to do something in a synchronized manner, and it has to be done very rarely, but the check for doing that is done frequently, in those cases you can use double check locking. Let me know where you have applied this concept in your project, and I'll be happy to share. Till then, please wait for my next video, which I'll be uploading on LLD, and I have also started a new series on HLD as well. If you have liked this video, please like it and subscribe to my channel. Till then, bye-bye.